motion perception is a heuristic, which means your brain has to figure it out. And Reichardt detectors are an example of that. It's having to figure out whether or not something is moving and deduce it. And so another way that the brain has to figure this out is something called corollary discharge theory. Corollary discharge is just a fancy way of saying that every time your brain sends a signal for your body to do something, it actually sends two signals. One, say, for the body part to move, and another signal telling other parts of the brain, hey, I just told my arm to move, or I just told my foot to move. Now let's apply that to vision and eye movements. And now imagine that you're watching a tennis match. Okay, so this tennis ball is going left and right across the court, and you're watching it. You're keeping your eye on the ball, tracking the movement of the tennis ball left and right. You're obviously telling your eye movements, your eyes to move left and right. The corollary discharge is that in addition to telling your eyes to move left and right, your brain is also informing other parts that, hey, I just told the eyes to move. And so that corollary discharge is going to be critical feedback that your brain uses to figure out if something's moved. So here we just have a simple little grid, a little 2x2 box that allows us to determine if something is moving or not. And so in one condition is that your eyes are told to move. In the other condition, your eyes are not told to move. They're just staring straight ahead. So we can think of these as a series of, two questions. Question number one, were the eyes told to move? Yes or no. The other condition that's important is an object that you're looking at and is on the retina, does it change its location on the retina? Does it move? Is it a moving object in terms of where its place is on the retina? So if the object that you're looking at, in this case maybe the tennis ball, moves across your retina left to right, then the answer would be yes. But if the answer is no, maybe I'm staring straight at the tennis ball, keeping it right in the middle of my fovea, or maybe the ball's not moving at all. And in that case, no, the tennis ball does not change its location on the retina. Over here, we have the information that the retina has about the object. Is the object moving on the retina, or is it not moving on the retina? And then up here, we have the information about the corollary discharge. Were the eyes told to move, or were the eyes not told to move? And that gives us these four different possibilities. If the eyes are told to move, and when the eyes are moving, the object is frozen in place on the retina. We have this situation right here where the object is perceived to move. So let's think about what's happening in that case. The eyes are told to move. Okay, so you're moving your eyes maybe because you're tracking this ball just before this player is going to hit it. Because you're tracking the tennis ball, you're keeping it right centered in your fovea. The object is not changing location on the retina. Your eyes are moving right along with the tennis ball, and you correctly deduce that yes, the tennis ball is moving. You're keeping your eye on the ball's moving through space, and you're able to figure out that the ball is moving. Now, how about in the case where your eyes are moving and the object does change location on the retina? So an example here would happen, for example, if we're looking at the fence here. The fence is not moving, clearly it's fixed. But if I move my eyes left and right across the fence, my eyes are being told to move, yes. And as I do that, does this post here on the fence seem to change location? You bet. I'm moving my eyes left and right. This is now ending up on different locations on my retina. It's moving around my retina because I'm moving my gaze. And that combination tells me that nope, the object is not moving. This part is fixed. So you can see that using the combination of what's happening in terms of the object's movement on the retina and what's happening in terms of the eye movements, our brain can figure out that there are two situations where movement is perceived. One is our eyes are told to move and we're tracking a moving object. And because we're tracking that moving object, we're keeping it right centered in our fovea. And yes, we perceive the object to move in that situation. The other one is when our eyes are not moving at all. We're staring straight ahead, and maybe we're staring straight ahead and this tennis ball moves in this direction. So if I'm just staring straight ahead, maybe I'm looking out at this tree behind the ball, and then I look straight out there, the ball will clearly change location. It's going to move around my retina. So no, my eyes are not moving, but yes, the object, the ball, the tennis ball moves across my retina, and I correctly figure out that the object is moving in that case. So just a quick little shortcut. If the answer to these two questions, are the eyes moving? And does the object move along the retina? If one is yes and one is no, we will usually correctly figure out that the object is moving. Now here's how we can figure out that this is a heuristic. And what that means is we're capable of making a mistake. We're capable of tricking our brains to a certain extent. Look here at the scene real quick and just look at the dot and close one eye. With your finger, try to gently move your open eye, your left eye, just by putting your finger on the lid, the eyelid. And as you do that, when you look at the screen, you might notice that the whole world is shifting in front of you, right? That is thanks to corollary discharge theory. When you move your eye without your eye movement, you're just forcing it to move without actually sending a signal to your brain to move your eye. You are telling your brain, hey, I am not telling my eyes to move, but this object is changing location on the retina because you're artificially doing that by moving, your eye with your fingers instead of and not generating this corollary discharge. And when you do that, you perceive that the object is moving. In this case, the whole scene is moving in front of you, and we have just tricked our visual system into mistaking movement where there really isn't any through corollary discharge theory.